Hello, everybody. We are going to be covering TypeScript for Swift developers. Like, what? Why is this even in the Swift track? Um, I am a developer who did mobile and Cocoa for a very, very long time, and now I am a compiler on the TypeScript team. So I think I have a good insight into both of these languages, and I think chances are it might be useful to you in the long run. Um, I have. It's a shame that I can't come to Mobile Optimized 2020. I've been to Mobile Optimized in 2014. I loved Belarus. I thought Minsk was fabulous. I just want to say good luck to Belarus out there. It seems like you guys are all in a bit of a bind. I'm currently in New York City, and so I feel for you. Hope everything's okay. Hope you all feel keeping safe. Good luck. All right. My name's Orta Therox. I have done a lot of open source in the last decade or so. For the first decade, that was a lot of CocoaPods, and I eventually moved to create and sort of maintain this ecosystem of tools called Danger. They give you a way to sort of do code sort of evaluation rules. And then I sort of moved to work in the JavaScript ecosystem after doing some React Native. And now I work as a compiler engineer on the TypeScript team. TypeScript is a really cool, interesting language. Do you need it to be a mobile engineer? Not at all. But maybe you do if you're doing React Native. TypeScript is a really well-loved language. Like we're talking like second most loved language on a survey for all programming languages on Stack Overflow. But to truly understand like why TypeScript exists, which I think we need to in order to understand the sort of interesting TypeScript things, type system things, you got to first understand JavaScript. So JavaScript is like the world's most popular programming language. It is, used in web browsers, and everyone has a web browser. It was built for small bits of scripting inside web pages, and now is used to power massive, massive applications. I don't know, like, I'm pretty sure everyone has at least one or two Electron apps on their computers. And, there's a lot of times when Apple use the web to sort of provide infrastructure for their own applications through WebKit. And so JavaScript is kind of everywhere. One thing that's tricky with JavaScript is that it doesn't have a way to describe types. Like, they're just not there. That feature does not exist in the language at all. And TypeScript brings the idea of being able to add static type annotations to JavaScript. And the way in which it works is that it tries to have every feature in JavaScript and then some. And that some is just ideally a type layer. And so what you conceptually think of as a compiler, TypeScript might not fit that domain. TypeScript's job is to effectively remove TypeScript syntax from TypeScript code to make it JavaScript. So in this case, it literally removes that interface and that sort of user down below, the sort of type definition for what the parameter is. And that's its goal. That's what it does. And so that's it. Whereas Swift, Objective-C, they have to create an entire runtime environment. They have to the Objective-C runtime is a thing. Swift has static dispatch, all of that sort of LLVM business. That stuff TypeScript doesn't have to touch. And JavaScript is such a big ecosystem that even TypeScript is like a tiny, tiny subset of it. And so the sort of TypeScript user base is perceived to us as compiler engineers as there are a gazillion JavaScript code bases out there that want to use TypeScript tooling, or just to them, they would think of it as JavaScript tooling because TypeScript can provide invisible tools for JavaScript projects. And over time, the people migrate to TypeScript codebases in the same way you would have migrated an Objective-C Swift to codebase to Swift. You would incrementally add some Swift and then slowly remove more and more Objective-C in favor of Swift code. And then, TypeScript has an extra mode, which is like a stricter version of the compiler that sort of people move to once they're comfortable in TypeScript. So for this talk, we're actually not going to be doing that much sort of presenting with slides. In fact, we're going to be using the playground. TypeScript has a playground which is a lot like the sort of Swift playground, but built inside a web page because, you know, that's the niche of Swift, of TypeScript, and this is something I built. I love it, and it's sort of the way in which people share code and sort of provide type ideas to each other. The way to think about it is that there is an editor on the left, so const hello string equals world. And on the right is a set of sort of tabs in which you can do different things. So this one just shows you what the JavaScript would look like. I could run it. It doesn't actually do anything because this code does nothing. And then there's a way to sort of generate a header file for this code. There's the plugins. These are all sort of plugins that a good chunk I've built, but this website allows you to build your own plugins to sort of do your own work. And then there's the plugin I built for this talk, which is sort of, it mixes my annotations about what the talk should be with all the code so that I can just sort of jump between code samples, which is actually what we're going to do first. So the first code sample is comparing a class in Swift and a class in TypeScript. There's really not that much different between it. Like, you know, you still have the class keyword, you still have the name of it, and then you just sort of make a section where you define each individual property. Nothing too fancy, but we'll never get back to classes. Where we will spend quite a bit of time and we'll sort of disambiguate later, like the idea of structs. So structs, you know, are pretty generic objects that can just sort of hold values. We will be using, like, this is JavaScript code rather than TypeScript, which we'll deal with later. But effectively, these two act the same at runtime. So, you know, this is a resolution that has a width and a height. That is a resolution when it's created with a width and a height. Then these are functions. Functions are also not that different. You know, there's a capital S for string. It's func in Swift and function in JavaScript, and there's a funky arrow instead of a colon. Nothing too crazy there either. Protocols in Swift are like kind of unique in the entire like programming language world. So TypeScript doesn't take all of their similar features, in part because types can never add runtime features. So like Swift's extensions are just not feasible, like design-wise, they're not allowed. So this is literally like an Objective-C one. You know, so there's an interface, and it says this must not be settable, so it's got to read and write, and this one does not need to be set, so it only has a read. Pretty cool. No, like, you know, nothing too far out of the normal there. One thing that is a bit weird is that there's two ways to define these, because you can do both an interface and a type. This is the last time you'll see an interface, so say goodbye to the class, say goodbye to the interface, and we'll be spending most of our time with type. Interface is very useful as a tool, but it's like, you know, we're looking at like Swift through a lens of TypeScript, and we need some more complicated tools, and type provides more complicated tools, and that's interesting stuff. But next we need to sort of talk about type space versus expression space, and this is where it gets a bit complicated. So we're going to look at some Swift code, and we're going to try and understand what a type definition like domains and what is expression space. So one way to think about it is, what is the code that has to be ran, and what is the code that is used to describe to the compiler? So in this code, we have a struct that we define a struct, then we create a function, and then we run some code afterwards. And in theory, all of this is expression space, but in a way of thinking about it, like this bit is code that is evaluated, and this bit is code that is evaluated. In theory, the rest could be like removed in some sense, right? Like this is used for the compiler to tell it that person.name exists and that this is a thing that this is like identifier that can create a person. But at the same time, it could just be nothing. And this is like a much closer version to what the sort of the runtime looks like, because like the runtime isn't necessarily doing type checking at runtime. There is, but it's complicated. But for a simplification, this is enough. To give you the same version in TypeScript, the code is more or less the exact same. We just changed the word struct to type, and change the colons. But and so we can start to now think, okay, so what does the JavaScript version of this look like? So I can show you. We can see that there is no reference to type here. There is person does not include this person, not this. And that's kind of it. So in theory, I can create JavaScript from my TypeScript just by deleting this. And it never changes the sidebar there. It never changed the JavaScript except when it thought that I had a typo. So that's that just broke the alt compiler, so that's okay. And that's interesting. So there is like a level, there are areas where TypeScript is allowed to add syntax that sort of provides type annotations, but none of that affects the JavaScript that comes out of the other side of the compiler. And that's kind of TypeScript's key goal, is to let the expression space be the exact same, but let the type space be different. And it's a hard concept to grasp at first, but it's kind of fundamental to understanding TypeScript versus JavaScript, because if you just jump straight to TypeScript, you don't necessarily understand what part is JavaScript, what part is TypeScript, so which makes it hard to describe problems to people and really hard to search for solutions. So this idea of like TypeScript not touching expression space is the idea that TypeScript wants JavaScript to flourish and to not be too involved in like adding new features to JavaScript unless they're about describing types. And I think this is what makes TypeScript succeed as a language, and why people love it, in part because they're like contrasting it with JavaScript, but also why it's won the browserish wars with a bunch of other competitors that are trying to like compile to JavaScript, right? They, there is languages like Objective-J, CoffeeScript, Dart. All these languages provide, extensions of JavaScript that provides, unique perspectives on how to, fix JavaScript's problems and run in the browser. But TypeScript actually embraces some of the flaws of JavaScript in order to allow your JavaScript to be the same as it is if it was JavaScript. I know, pretty wild and pretty hard to describe, but JavaScript in TypeScript is just JavaScript, and JavaScript in JavaScript is JavaScript. Okay, so whilst that will still be a little bit hard to get around your head, that's totally okay. We'll start looking at some of the interesting things about JavaScript, in my opinion, about TypeScript. In fact, the first one actually is about JavaScript, which is why it's a little bit confusing. So let's look at some Swift. I found this code in Alamofire, and what this code does is it's a function that creates an object, and it is well documented. Well, it is documented, not necessarily documented well. It's just like they just repeat themselves basically here. But this last one is pretty useful. And this is a way of providing developers information about the parameters as they're typing. TypeScript has this, so does JavaScript. But what's interesting is that TypeScript allows you, the TypeScript tooling allows you to describe the type system inside a comment. So you could be in a JavaScript code base and you could actually use this sort of comment syntax to describe your entire type system. And so if we look at the sort of JavaScript output of running TypeScript on this code, there's no difference. They're basically the exact same, except this use strict, which is always added by the compiler. It's a thing. You don't need to care about the details. So this is totally normal JavaScript. This will just run in a web browser, fine. This is obviously the same too, but this adds code comments which define the type system inside here. And you can get your editor to automatically provide errors based on those code comments. And so this entire type system that we're about to explore can be, by about 70%-ish, represented entirely in comments. Isn't that wild? So that's one of the first sort of things that we're going to talk about. Next up, we're going to talk about how the type system works under the hood. So the type system in TypeScript is it's like, well, the TypeScript in Swift probably is the first place to start. This code would not work in Swift. We are creating a struct called resolution and a struct called rectangle, and we create 2 instances of it, and then we try and set them. This fails. In part because, a resolution cannot be a rectangle. Those are 2 separate types. Those types, the only thing they have in common is the way that their fields are declared, but that doesn't mean that they're the same. So you can't switch between them. Whereas in TypeScript, that's exactly how it works. That's how the entire thing works. TypeScript is a structural typing system, which means that it only cares about how the individual properties come together and are compared. So the way to think about this is that when we look at the JavaScript, it really gives you a sense of what bits are actually ran and what bits are completely removed. So if A and B are both an object of width 100 and height 200, then those are the exact same types of objects. There's no conceptual difference between them in JavaScript. And so what TypeScript does is it effectively says okay, so we're just going to compare every single part of an object and see if they fit within each other. And if they fit, then they're the same. So A can be a B and B can be an A in this case, and that's totally acceptable in TypeScript. Whereas that would totally fall flat in almost every other mainstream language. Sometimes this is called duck typing too. Generally, when you see duck typing, that means there's no types. Whereas TypeScript obviously has a rich type system, and yet still has a lot of sort of ways in which it compares these objects. So structural types are super cool. And what we're going to look at next then is what it looks like when when we take these extra fields and we sort of extend it, right? So this is still the same type, rectangle, and in this case we've now added X and Y to the object, and it still has width and height, and that can still be actually passed into a function that takes a rectangle. So there's no problem here, right? Remember I said it structurally checks, right? It checks that width and height are inside the object that was passed in, and that's totally fine because this function will pull out width and do something with height, but it doesn't necessarily matter what it does with the rest of the object because it's just a dumb free-floating object, and you only care about the sort of the width and the height in that function. As you can see in the JS, it's just create the object, the function exists, run the function, and the function would use width and height inside that. And this is cool. What's really interesting is that the type system gives you different errors depending on where you declare this rectangle. So if I instead wrote that this object was a rectangle right when I created it, then TypeScript will actually give me errors saying that it didn't know that X and Y existed. So it's saying here that the object literal may only specify known things, and X does not exist on rectangle. So depending on where you put the type definition, you get different compiler errors, even though that was the exact same code in the JavaScript here. So that was the exact same as what we saw earlier. But because we added this rectangle here that said during the creation of this thing, then it knew that it could only be those things. And that those fields. And that's a kind of interesting property of TypeScript. So that's pretty cool. I'm a big fan of that. It helps you in a lot of different ways, subtly, and it's one of those things that's kind of hard to get your head around at first. Next up, we get to talk about one of my favorite features, and here is creating a login message in Swift, and here is creating a login message in TypeScript, except the thing here is this creates a string like you'd expect. Let is actually not the same as let in Swift. Let is var in Swift, and const is let in TypeScript. So you would use const there instead of let if you were going to make it so it didn't change. And that difference here is kind of important. So if I hover this now, we get a completely different type. It used to be string, but now it is welcome danger, which is wild because what it has done is it used to be mutable, right? So it could be any string it wanted to be, but now that it's a constant, it can only be this one type. That string has gone from every single possible set of characters down to one possible set of characters. It still is a string. It just happens to be a string that represents only one known set of characters. So I can still do, login message dot length, like as though it was a string, but it has been narrowed down to be a specific instance of like the infinite set of possible strings that could happen. Like, that's pretty wild. This idea can be used in your types. So here's a rectangle, and the rectangle has a name now. And this rectangle's name can only be rectangle. It can't be anything else. So if I created a square, it's a type of rectangle, and made the numbers the same. I couldn't actually call it a square. That's just not allowed. That's what this types error is telling me. Like, it expects it to be called rectangle. And so I have to write rectangle here. Huh. Very interesting. Like this is something that you can start building upon, basically. So if I look at the next example, like, we've got a function here, and that function takes a path. That path is API artworks. So when I call it, I can only pass /API/artworks in there, nothing else. And I could delete that, and I get an error. If I bring it back, then it comes back. And whilst this example is completely contrived, and nobody should ever build something like this, what this allows you to do is super powerful and super cool. So we've talked about, like, this only allows it's one single string. So what do we need if we want to allow multiple strings? And to do that, we need a tool called the union type. So this version of that code now has an or something in the type area. And if I do get API, now I have the option of /API/artworks or /API/artists. And this is where it starts to get fun, because we're describing like exact strings as though they were very similar to like a real type. They're obviously a real type in TypeScript, but like most programming languages just allow string. They don't necessarily allow an exact explicit string itself in that. And this is kind of because there is no, like, JavaScript doesn't have enums. So there is no way to describe, like, you can't ahead of time say that, like, it can only be one of these three values, and I build a thing that, is like a Boolean but more options, and like enums can act like. You actually just have to use a string or a number in that place. And TypeScript, in trying to describe existing JavaScript, well, it has to treat those as special values in order to sort of provide useful, interesting sort of systems. And so how people tend to write this in practice is more like this. I have extracted this like idea of API artworks into a new type. That's what type is here. Like, your type alias exists in Swift, I think, and this is actually what this represents here. This is a type alias for API paths. So this now has the name API paths, and I can just use it here as a normal type. So that is the exact same, but now we're starting to see what type does, whereas previously we only ever used it for describing an object. So have you ever seen something like this before? Kinda. Like, in Swift, the sort of the or nil representation of sort of optionality, the question mark, that's very similar to what we're thinking of here. So like, this code, defines a name, and only if name is set in the environment will it actually get set. And so at this point here, we don't know in TypeScript type actually that's running TypeScript over Swift. So the TypeScript in this case, a string with a question mark is either a string or nil, and it's one of those two. And it's on until you check, you don't know. It's Schrodinger's string. And TypeScript's sort of unions act the exact same, but just with as many different possible fields as you want. So to try and get a sense of what that looks like in practice, we're gonna have some API responses. So here's an API response for success. Here's one for failed, and here's one for not found. This is pretty close to what people will do in practice. You have a status code, so the number sort of represents like this can only be 200, this can only be 401, this can only be 404, and you can create a union type of these three different objects, and say that like basically I have an API response, and it could be one of these three things, any of those. We don't know which. It's kind of on you inside the code to decide. So in this case, we've got a function that sort of handles a response like this, and we do a switch on a status. You can see here the status can be either 200, 401, or 404. Very similar to what we've got going on here. And depending on which one it is, we get different properties available inside our response. So this switch acts exactly like enums enums with switches in Swift, and it changes the sort of types down at different levels of that switch statement. So this acts a lot like these sort of attached objects in enums. And so the pain points that enums with attached objects fixes is also addressed in this format by the use of string literals for the language. And like it's interesting to see how both of these languages sort of attack the same problem of I need to have something that represents many things, and those many things could have unique properties inside them. TypeScript says, well, dumb objects with a way to sort of check between the few of them, and enums have straight up like these things are completely definitely separate. So it's really cool. I think both answers are really interesting answers to the same problems, and that's how TypeScript solved it. Next up, we're going to look at generics, normally the part where people start sort of turning off, but we're going to try and keep it really light. So if you've never used generics before, generics are effectively a way to provide variables to types and functions. So in this case, there's a sort of variable on the struct, and that is the body type of the API response. And so we have a status and a body. That body type is whatever came in here. So when I have an API response success here and I say it's an artwork, that body artist, then this has to be an artwork or whatever. I'll allow it to be broke. This has to be the body of an artwork, and that's how generics generally work at a simple level. This TypeScript code is more or less the exact same. I just added an extra type in between. I could have just wrote this, and now they are more or less line to line the exact same with just the word struct switched for type. So again, there's an API response, it has a type and it represents that. And then here I've created one, and this title here comes from here and it has to match up. And that's what generics are useful for. What TypeScript has on top of that though is the ability to sort of do pipelines of type transformations, and that's what we're going to look at next. So we've got, we're going to represent a HTTP client, and we're going to try and represent it in the type system first. So we've got a get, a post, a patch, and a delete. If you've never done REST APIs, these are the sort of four main ways in which you interact with a sort of resource on a server. You do a get to download it, you do a post to create a new one, you do a patch to update it, and you do a delete to delete it. And each one has different rules about what you should send. And we're going to try and represent all of these different types in a sort of pipeline way rather than trying to describe them like this. So the get is easy. You just take whatever object you have and that's what you return. So artwork get equals artwork. That's we're just gonna move straight on. The next one is interesting. So we have the typo in TypeScript. We have artwork post, right? The artwork post is sending as much information as possible, but you do not send the ID because you don't have the ID at that point. You're just trying to create a new object and it will give you an ID back. So we have a type here called omit. You do not care about the implementation details, but effectively it takes a type and then it removes bits of the type from it. So artwork post only has a title and an artist. It has ID removed. I can add a new field. number, and it shows up in here because we have taken the existing type and we've just removed ID. So you can see a bit of pipelining here. We call these mapped types. The next one is a little bit more nuanced, and I'm actually showing the real code under the hood here. So we need to get a version of the object where everything is optional, where you can only send a subset of that object. So this artwork now has a title and an artist right now, and we're going to put it through this myPartial type. And myPartial type will effectively look through every sort of option in the field and add this question mark to it. You don't need to understand the syntax. Don't bother thinking about it too hard. Just note that there's a question mark, and when we do it here, that question mark appears everywhere else. So again, it's taken this artwork and it's sort of made a version of it with question marks everywhere. That's not enough though. We actually have to have an ID. So we take the original one that's all partials, and then we use this and ID with an object to sort of merge these two types together to create a new one. So we've taken sort of two bits together, and we've sort of first taken this partial with with ID being optional, which is wrong. And then we've created a new object, which is a merge of the partial artwork and the ID. So we've done a bunch of type manipulation to eventually create this params, where the params has to have an ID, so you don't see a question mark here, but the artist does, and so it does have a question mark there. It's kind of interesting, kind of hard to get your head around the first few times, but like you start to see how type manipulation can be very powerful. And the delete, you only send the ID, so I don't even have a demo for that. So what we're going to look at then is this HTTPify, and this is like, if you're welcome to be like zone out if this is a bit much, but this is a type that's generic, so it takes a type in, and now we're starting to work all those examples at a higher level. So for get, it just returns the type, so the thing that was inside. For post, it omits from the original type variable the ID. Then for the patch, it takes the partial of the type that came in and then adds an ID string. And then for delete, it takes an ID string. And then when you use this client, you can just do HTTPify whatever object you put in. So this client now has a delete, a get, a patch, and a post. And I can sort of dive in and get any bit of this out that I want. So if I add a new thing here, so if I do, birthday, it's an artwork, so artworks have creation date. Sure. And if I do that, then my get will now include that automatically. And so we have this type that does a bunch of little pipeliney bits over the original artwork. And you may be wondering, well, why would someone use this? Good call. TypeScript's job is to describe existing JavaScript and to not have people rewrite into TypeScript. So in order to describe like the huge amount of JavaScript out there, we are doing as much work as possible in these sort of pipeliney types. And that provides a ton of useful value to people trying to sort of come together and make really cool sort of type definitions that can allow you to describe really complicated types that are already available online right now, right? Like TypeScript types can define sort of jQuery or libraries that even predate that. And that is like a super powerful concept, because we can't go back to an old like library and just say, okay, jQuery, convert yourself to TypeScript in order for people to use jQuery. And TypeScript has to be able to define how an external library completely works. And it's a continual progress of like adding more and more interesting type system features in order to actually get to a point where the type system can work for sort of anybody and in any case. And so that's what TypeScript is. Have a good time, everybody. I know I'm a little bit over, but it took me a while to get this reduced down to from this time. So have a good one. Black Lives Matter. Good luck with Belarus stuff. That's pretty wild. I'm watching, and stay safe.